In this tutorial, I'm going to be demonstrating how to use the temporal analysis functionality in RARECAT and how to make sense of its output. First, I'm going to start with a subnational assessment in California. And then I'm going to choose the species Monardella viminia. That's the willowy Monardella, which is an extremely rare native perennial herb in the Lamiaceae family. That's the mint family. And this species grows exclusively in San Diego County, and it has been known to undergo some declines recently. So let's add all the GBIF records for the species. And there's one more thing I want to do in preparing these data, and that's to remove these couple of records here that seem to be associated with the location of a herbarium. Okay, so I've cleaned up the data set, and here's the distribution of all records that came in through GBIF. I also want to turn on the area of occupancy calculator here. And as you'll see, the area of occupancy grid cells here that have been determined for our assessment taxon are being mapped. And this is by no means essential or necessary at all for the temporal analysis, but I just wanted to have those on the map because they'll be useful for us to understand how the temporal analysis works under the hood. Okay, so let's go to the temporal analysis tab, and you'll see that we're being asked to select two parameters. The first one is pretty self-explanatory. That's the start year in which we want to begin assessing change. So that's going to be setting the time frame of our change analysis. The second parameter identifies the taxonomic group with which we want to be comparing the pattern of recording in our assessment taxon. So I'm going to be choosing the family at this point. And with these parameters selected, what's going to happen when we hit calculate temporal change, I'm going to click that now. What's happening now is that RARECAT is downloading all GBIF records for the entire family that Monardella viminia belongs to, so that's the mint family, and going back to the start year, so that's 1950, and crucially, the area over which these records will be downloaded is exclusively the area contained by the set of area of occupancy cells that have been determined here for our assessment taxon. So you saw that didn't take too long for this species, but in some cases, downloading this data set could take quite a while, especially if you're assessing a very wide-ranging taxon and you're picking a reference taxon that has a ton of data in it, perhaps the order of the class or the class, and you're going quite far back in time as well. All those things could determine a very large data set to be downloaded from GBIF. In some cases, that might preclude the analysis of temporal change altogether. And so in those cases, you might want to change your parameters to result in a smaller data set. You'll see that what we've received is an output that is comprised of three different plots. The first one is quite simply the number of records of the assessment taxon in each year. So this is somewhat similar to a plot you'd already seen in the previous tab. As we can see here, it seems that in 2022, there were the most records collected for the species in the area. That's 18. The second plot shows the total number of records across the whole family that our assessment taxon belongs to. So that's the family Lamiaceae, the mint family. And again, we can see that in 2022, the number of records seem to be the highest over time, and that's 190 total records. The third plot is what we want to be looking at in terms of trying to tease apart the pattern of temporal change for the species and the ecological signal of potentially decline or expansion over time. What the third plot does is that it puts the records of our assessment taxon in the context of records of the entire family or the reference taxon that has been chosen. So in other words, it is essentially the first plot, numbers in the first plot divided by numbers in the second plot. That's what you see here displayed on the third plot. So, for example, in 2022, although we had the most records both of our assessment taxon and the family that it belongs to, in relative terms, that proportion of records of our assessment taxon is actually quite low. And you can see that we've seen a steady decline since the late 1990s, early 2000s in the relative proportion of records of our assessment taxon within the entire family. This probably gets closer to the actual ecological signal of change in local abundance. And it's probably what we want to be looking at more so when trying to identify potentially useful signals of temporal change when ranking a species.